All right, how's it going? Got any questions? So let's talk ODPs. So ODP 415, this calculate function, I still saw some people turning in code that worked but was doing way more work than they needed to, where they were actually like converting character by character into an integer. And some of the stuff that we talked about yesterday, but that I didn't ask you to do for the ODP, because if you're doing scanf, that's doing all of that work for you, right? This one statement checks the syntax of this string called buffer, make sure it's an integer followed by a character followed by an integer, and if it is, converts those two integers into these variables n1 and n2 and stores that character in this single character variable op. Right? It does all of that parsing, that translating from a bunch of text into an interpretation of it. And then we can check the return status from scanf. And if it's not 3, it did not parse correctly. It didn't match that syntax, right? So that's a syntax error, return -1. Otherwise, you can do a set of if statements. If op equals plus, then return the sum of your numbers. If it's minus, return the difference, and so on. I did a switch statement here, but it's just a glorified set of if statements. And the default case on a switch matches if nothing else above it matches. And so if it's not the case that operator is one of these 4 symbols, then we return a -2, which says illegal operator. So any version of that should assess correctly. And it's really just kind of cobbling together by hand a way to evaluate an expression. A very particular expression, right? But still, it's the start of something that could be much more general to do arithmetic expressions. So today's ODP is similar to stuff we were doing last week on the board, which is basically you're taking a string, you're trying to remove any occurrence of the letter X from it, and then return that cleaned up string as the second argument of the function. Network's been kind of problematic this morning. It seems to be problematic again.
When you say remove X, is this replacing it with just a blank character at that point, or just should we
No,
shorten
it's shortening the string.
Oh.
So if your input string is like this.
It should be A, B, C, D, E, F, G. Okay.
Yeah, it should be. So when you call this remove function rem, you pass that long string with the x's as your first argument. You just pass an empty string that has space in it as your second argument, and your function should replace that second argument with the truncated string. And you can use the string length function, but don't use any other functions from the string library, because there's functions that'll do things like this for you. So don't just punt to those. Go ahead and do this sort of barehanded. And so the question is, how do we write code to do this? And if you already know how you're going to do this, that's great. If you've already done it, that's great. But if you're not sure how to proceed, here's a suggestion on how to tackle things like this. Think about how you would describe steps that somebody could follow to turn this input into the desired output. And in describing the steps, you don't get to look at the input. You can't say, okay, so write down an A and a B followed by a C and a D, right? You don't get to know what the input is when you're describing the steps. And the person you're describing this to has to follow whatever steps you tell them But you can't tell them fancy things like, well, just remove all the X's, right? You got to do steps that are basically on par with the things we could tell a C program. So, so how would we describe a procedure for turning this into that? Let's just take a shot at it. So what's the first thing we could do? Or a first thing? Yeah. Okay, look at the first character. And let me name these things. Let's call this old. Let's call this new. So look at the first character in old. And what do we do after we look at it? Okay. If it's not an X, what do we want to do? Okay, otherwise, do we want to do anything? So, if the first character is not an X, then we'll just set that as the first character in new. Okay, and then what do we want to do? Second character. So far we've set this equal to A and we've set it equal to B. So let's go to the third character. And that's an X. So we don't want to do that, set the third character. Okay. So look at the fourth character. And that's the letter C, it's not an X. So what do we want to do with that C? Okay, so we want to set to the third character in new. So we want to put a C right there. Okay, so this works well. But there's something going on here. We're looking at the first character, the second character, the third character, the fourth character. We're saving in the first character, the second character, the third character, the third character, right? So what does this suggest? That it goes on and on.
Check for a null terminator.
And we'll have to check for a null terminator to know if we're at the end, right? So do until we get to that null terminator in old. So how do we codify this? Because there's nothing in C that says look at the first character, look at the second character, look at the third character, right? So we use an index, right?
Instead of looking for a null, couldn't you also just have a for loop that runs until string?
Or you go for until the string length, yeah. Yep. So how do we codify looking at the first character and then the second and then the third and then the fourth? Yeah, so so we can initialize old I to 0. That's the index for old. When we want to look at that character, we just look at old bracket old I. And if it's not equal to an X, we're going to do something. And then at the bottom of our loop, we can just increment that old index. And now the next time we go through this, we're going to look at character 1, check character 1 for an X. The next time through, we'll look at character 2, and so on. So if our character is not an X, we want to take that character and save it into our new string, right? But sometimes that position we're saving at is the same as the position we read from. Sometimes it's not. So someone said two variables, right? This is the two pointer thing. So we also want an index for new, which we can initialize to 0. And when we want to save a character in new, we copy it into index new I and we increment new I. So new I is always the place we're going to put a new character into. Old I is always the place we're going to read from. And we do this until we get to the null terminator, so we can use a for loop, or we can do this while that old character is not the null terminator. And then you just got to do one more thing at the very end. Because we'll have written all of that into our new string. And there's always one more thing you got to think about doing. And null terminator. And if we have this idea in our mind that new I is always where the next character should go, this will probably turn out to just be new bracket new I with a null terminator. So something like that. So this is definitely one to play around with your own test program. Okay, there's a bunch of test cases in the assess. So you want to make sure that you test this with a bunch of different test cases. So what are some of the test cases we would like to use on this function? Say again? All x's, excellent test case. And that should return a string of length 0.
Capital X's.
Capital X's, which it should not pick up. Right, it's only removing lowercase x's. What else? No x's. That's an edge case. Anything else? Cool. Anything else that might be edgy? Yeah. Or a bunch of x's on the end. Or x's in the beginning. Or a bunch of x's in the beginning. Or a bunch of x's in the beginning and some x's in the middle and some x's at the end. And I can envision different ways to write this code that might break some of these cases and work well in other cases. Also, try a totally empty string. String of length 0. That's always an edge. So that's probably a pretty good set. But anyway, there's several cases you can try, right? And you can type these in if you write a main program that uses fgets. But remember, fgets throws a new line at the end, so it's hard to test things like, is the last character an x? But you can just hardwire these, right? Just pass these things as the first argument to your function, pass an array to the second, print out the array after each call. So lots of test cases. How do we get rid of that new line on the end of a string array that we read with fgets? Missed a semicolon, didn't I? Last bracket.
Closing bracket.
I'm not seeing it. What line?
Closing bracket.
Oh, yeah. Thank you. All right, so usual thing, right? We read with FGETs, this is a test, and when we print it out, it's got a new line sitting on the end. So we'd like to get rid of that. So this is what our input looks like from FGETs. What's the easiest way to dump that new line, to remove it from the string effectively? Okay, but I don't want to scan through the whole thing. I just want the new line at the very end. Yeah. If we could somehow just reduce the length of this string, if we could just put a null terminator in place of that new line, that would be where the string ends, and there's no new line anymore. So the question is, what do we put in here? What's the position of that null term, of that new line that we want to get rid of? So string length of string minus 1. So what's string length of this string? 7, 6, or 5? How many say 7? How many say 6? How many say 5? Oh, the 7s have it, but that's wrong. So string length does not count the null terminator. So it's 1, 2, 3, 4, 5, 6. So string length is going to be equal to 6. And if we look at index, string length minus 1 always gets you to the last character of the string, which is a new line, right? The null terminator is not considered part of the string. So if we set string bracket string length minus 1 to a null terminator, that will replace the last character, which is that new line, with a null terminator, which basically gets rid of the new line. So we're going to get string bracket string length of string minus 1. Set that equal to a null. I forgot to include string.h. All right, so the old string was this is a test with a new line. The new string is this is a test without a new line. And that's a snippet of code you'll find a lot. All right, so questions on ODP. All right, so let's go back into regular expressions. So regular expressions we were playing with in VI, and we were mostly doing substitute old / new. Right, which says look in the current line for this old pattern, replace it with a new pattern. We could also say substitute old / new / G, and what does the G do? Did we talk about the G? G is global, so it says everywhere on this line replace the old pattern with a new pattern. So if I say down here, substitute I with 3 I's, right, that first I gets replaced with 3 I's. If I say substitute I with 3 I's slash G, everywhere that an I occurs on this line, it'll get replaced with 3 I's. So it picks up both of those. And we can also do colon first comma last, substitute, and put in any of our substitute expressions. And this repeats it on a series of lines in our file. So we could say 2 comma 4, or let's say 3 comma 5, substitute a space with a bunch of Y's. And so on lines 3 through 5, the first space gets replaced with a bunch of Y's. And if we want to do the whole file, we can say 1 comma $, because $ means the last line of the file. And we can replace every occurrence of a space with 3 Y's and say do that everywhere on the line. And now all our spaces have changed into something else. So $, means last line. The first line is just 1, as usual. And so this old pattern can be characters. It can be a period, which is a wild card, which matches anything. It can be a star. Do you remember what star does? Yeah, it's kind of like a wild card. It says match 0 or more. Global. So match 0 or more of the prior character or pattern. G says do it everywhere on the line, not just the first place that it occurs. So if I say substitute, well, it's so if I say substitute space followed by any number of spaces and replace that with, I don't know, the letter Y, right? So let me use an underscore for a space. I'm asking it to match a space followed by space star. Well, this matches a single space. This matches 0 or more consecutive spaces. Okay, so I'm asking it to match a space followed by any number of subsequent spaces. So this pattern of 3 characters matches basically any set of at least one space. And I'm asking to replace that with a Y on every line. And so that gets rid of the first occurrence of multiple spaces on each line. And then the 2 other special symbols we need are caret and $. Caret matches the start of the line. $sign matches the end of the line. And that gives us enough to do the majority of search patterns that we want. What is the what? Asterisk. Asterisk matches 0 or more occurrences of whatever comes right before it. So for example, if we say period asterisk, that'll match 0 or more occurrences of any character. So if I do something crazy like substitute period star, that matches, or let's just do period star. Substitute 0 or more occurrences of any character with the string haha. Well, it starts at the first line, and it says, is there 0 or more occurrences of any character here? Okay, so regular expressions are greedy. They will match as much as they possibly can. So yeah, a single character 1 certainly matches 0 or more occurrences of a character, but a 1 followed by a 2 also matches that. And a 1 followed by a 2 followed by a 3 also matches that. And in fact, the entire line can be described as 0 or more occurrences of any single character. So this pattern will match the entire line and replace it with ha-ha. And the same thing on the second and the third and the fourth. And so it basically replaces every line. So we can do pattern matching with these things, and we can match at the beginning or end of a line if we want. And that's part of what regular expressions are for, but it's not the main, most powerful part. The most powerful part of regular expressions is that this new pattern can contain information about what we matched in the old pattern. We can say not just look for particular characters or particular combinations of things over here, but remember what you matched and use those in deciding what to replace that old pattern with. So let me give you some examples. So here's a file of names. Suppose I want to change this from first name space last name to last name comma space first name. I want to just swap the first and last name where they're separated by a space. And I'll put underscores here to make the spaces clear. Okay, we want a pattern that matches the first name followed by a space followed by a last name. And the space only occurs in between the first and the last. So I'm going to use that to pick out what's the first name, what's the last name. So I'm going to match the beginning of the line followed by any collection of characters followed by a space followed by any collection of characters followed by the end of a line. Now I could have just done dot star and we know that matches a whole line, but by doing my pattern matching like this, I have a pattern that matches the first name, a pattern that matches a space, and a pattern that matches the last name. Okay, so here's the cool thing. If you throw parentheses around these patterns, the thing that's processing this regular expression will remember what part of your string matched these patterns. And it will take the part that matched this and throw it somewhere called register 1. And it'll take the part that matched this and put it somewhere called register 2. And register 1 I can access by saying \1, and register 2 I can access by saying \2. So I'm matching a pattern, first name space last name, and I'm saying get rid of all of that. So this is going to wipe out the entire line of text and replace it with whatever I put over here. So what I'm going to put over here is the contents of register 2, and I'm going to follow that by a comma and a space and then the contents of register 1. So that's going to take the entire line and replace it with last name, comma, space, first name. And just to make it a little quirkier, these parentheses need to be escaped, so we need to put backslashes in front of those. Just because that's how regular expressions work. So we get this big, long, horrible expression, but it will do marvelous things. So $1, substitute beginning of line, any number of stuff, followed by a space, followed by any number of characters, followed by the end of the line with second character, comma, space, first pattern. And don't try to read these, okay? They're impossible to read. But try to envision how we decide to write this regular expression, right? Sequence of characters followed by a space, followed by sequence of characters, followed by the end of the line. So this is first name, space, last name. And the parentheses, the backslash paren, backslash close paren, put these into registers. This is the contents of register 2, last name, comma, space, contents of register 1, first name. So it does that. All right, well, I've got that. And what I'd like to do is change this into just first initial instead of the first name. So I'd like to get rid of, in this case, the ICK, right? Everything after that first initial, and I'd like to replace it with a dot. So again, I can use this space to know where my name begins. So I can say substitute a space followed by a character, followed by any number of characters, followed by the end of my line. And let's replace that with a space, followed by the first initial, followed by a period. So I need to capture whatever it is that matched this period, whatever character matched that first thing after the space. So I'm going to throw that inside parentheses, which means this is going to be available in register 1. And so I'm going to replace that first initial followed by the rest of the first name with a space followed by contents of register 1 followed by a period. Like that. So these are really confusing to try to read. Okay, they're a whole lot easier to write than to read. I don't do a lot of testing on these because I don't want to try to read these and understand what they do. But synthesizing these expressions is something you can get used to with practice. And it's ridiculously powerful in a number of contexts. So anytime that you have a data file that you're trying to do some processing on, it may be that if you change the format of the file, it's easier to process. Maybe you have a comma-separated file, but you'd like it to be separated by spaces, or vice versa. Or you have a file where you'd like the first 2 columns to be reversed. Or you'd like to take any column that has a certain pattern inside it and change the order of the columns in that particular row. And there's just all kinds of things that pop up where you can use this. So if I'm getting lots of questions on an ODP, right, I want to go to the grade file and I want to see how many people have tried this, how many people have gotten 100% on it, right? And I can pull out those lines by just doing a regular expression like this, right? I can search for 40/40 and do something to pull out the first name and so on and so forth. There's a language called Perl. It was popular in the 80s. It was backbone for a lot of the web in its early days. And Perl understands native expressions natively, understands regular expressions natively. It has built-in syntax for doing these kinds of substitutions and pattern matching. Because so much of what you do in processing web pages is taking an input and breaking it up into certain pieces, or taking a web page and modifying it and serving up information in certain contexts. And this stuff just chows on it. You don't necessarily need to be fluent in regular expressions to be successful as a programmer, right? Or to be able to work comfortably in a Unix environment, but it will definitely help, right? It will absolutely help in living and working in a Unix environment. And most modern programming languages understand regular expressions. They're built in. Java has a huge regular expression package, for example. And if you're comfortable with using it, it can make your life a whole lot easier. It's a backbone for parsing, for doing compilation, for doing text processing, all kinds of things. And it really, there's tons of things that go into regular expressions, but it's really just kind of this small subset of matching particular characters, wildcard, 0 or more occurrences, anchors that put you at the beginning or end of a line, and escaping patterns in parentheses to throw them into registers and then replacing with those. And with just that small set of 6 or 7 tools, you can do a huge number of things. So let's play with 1 or 2 of these, and then I want to have you go on the board and work on some. Oh, we've only got 10 minutes. Let me do 1 of these as a class. So suppose we want to get rid of the first character on each line. Okay, just wipe out the first character. What kind of pattern might we use for that? So we want to take the first character and just eliminate it. Okay, so let's put an anchor for the start of the line. And then a period to match 1 character. And we want to replace that character with nothing. So we can just say take that pattern, replace it with nothing. And that's all you need. All right, that gets rid of the first character. Now, what if you want to get rid of just the second character? Say again? Don't necessarily. We actually want the second character.
Could you load the first and the second into the register, or could you load the first into a register, delete both the first and the second, and then bring back just the first?
Okay, so the suggestion is match the first and second characters, right? Delete them both, but replace them with whatever matched the first character, which means throw the first character into a register, put it in parentheses, and then just replace that with \1. So that matches the first character, that matches the second. This says take the first and second character, get rid of them, and replace them with the first character. Since we're taking the first 2 and replacing them with the first, that's going to get rid of the second character. All right, making some sense? So let's get onto the board and let's try some of these. So let's start off with swap the first 2 characters on a line. So try to write a substitution pattern that'll swap the first and second characters with each other.
What you want is the dot store one register.
Could we replace this with a carrot?
Actually, that didn't work. You can still do one though.
Can you replace the one with a carrot?
Replace what?
The one with a carrot to signify the start of the
I
file?
think maybe you can, but it's always line 1, so.
Okay.
It means the same thing.
But the dollar sign's there because we don't know what the last line number is.
Yeah.
And then,
Okay, so remove the first three and last three characters from the line.
So try
Try this one?
try removing the first 3 and last 3 characters from each line.
logically, I just don't know if we're
Now, you can store 3 at a time, right? Just dot, dot, dot.
All right, if you're done with the first one, go on to the second one.
Yeah, select the end of line. No. Select. I should remember if I did it.
I'm starting.
Actually, how would you do it?
Yeah, how would you go back?
I'm sure it has something to do with it.
Oh, you probably. That's the way I remember it, whatever. That's the way I did it.
That's what?
Yeah. I just remember the dot slash. Oh, because slash. I don't know why I did it. The cat sign.
Dollar sign minus 3 or something.
And then 3 dots you did the time. It's like the first 3 characters.
I don't know how to go back.
Oh, I know. I think you do dot, 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 dollar sign.
Yeah, that's what I'm not like.
What about the last 3?
Pattern match.
I didn't try to get us all doing it.
Basically.
Oh, yeah.
So we're just swapping them?
Yeah, right.
Oh, no, we're removing them.
Yeah, it's like, I feel like that because I was
So this needs to go, or no, we're not saving them to register, we're just deleting them.
Yeah, you can start with that. And
We're not, like, how would we find, like,
Before the end.
So that makes basically matches 3 characters and then anything and then 3 characters.
so anything in a register, and then replace it with that register. So, okay. Let me try that. So we have the start and the end of the line. We want to match 3 at the start.
Side is in a little back.
Now we want to match everything in between that and the last 3 at the end of the line.
So put a period before the asterisk.
A period start. And we'll want to store that in a register.
Number and then 3, and like that, it'll get rid of the whole line. Yeah. Right. But what do you want to replace that with? That's the whole
And then we'll
line.
replace it with that register.
So I can just replace, I would basically do like
you have to call a register?
Oh, yeah, one.
Or no, no, have that one.
Say what?
We need the separate.
Oh, so these,
And then we need the register symbols for that, to save this as a register. Yeah, I guess it has two forms of parentheses. It's just the backslashes. Another one out front. Out front. It's out back.
Yeah, seems like that's what everyone just.
Yeah, I think they said that we needed to store it like a register.
this is match the end of the line, three characters.
So you can see like from the start of the line, match everything
Between there and the last line.
So you have like, if it did, then it wouldn't be able to match.
So the first two characters flash three characters. The first two store in a registry. Start of the line. The first two store in a registry.
I just saw a slash.
So what are you trying to match after the first three characters?
After the first three characters?
Yeah.
You take the first three characters.
So then everything between those last period is
If you just do dot, 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 sign,
Just swap the first and then swap the first.
well, that will match three characters in space.
Swap the first one.
number 4.
So it could be three characters, it could be three characters.
I was gonna say, I was like, what one are you doing?
Or it could be three characters.
So we did 3 by doing this as well, because this pretty much tells you that. I guess registers are just numbered like 1, 2, 3.
Yeah, in order, however many you have.
So if you,
And then the first 2.
but this might be three characters, two characters, three characters.
We're out of time.
Yeah, we are.
Do you want to meet after physics and try and get our physics, figure out what we're doing for our lab? Or not our lab,
I
our...
have calculations right after physics.
Uh,
That's until 3 o'clock.
I might still be here at 3 if you want to do it at 3.
Yeah. So you want to meet in like SVG 125?
You got this? Cool. Cool. All right, so we'll keep at this tomorrow. I'll see you then.